Yeah, welcome back. So in this lecture, today we are going to discuss about a MAC protocol in wireless networks. So especially in the case of wireless sensor network, we are going to discuss about the MAC protocol. The content we are going to discuss here is the classification of MAC and why the MAC is required for wireless sensor network and the related properties of MAC and how we are going to use the energy efficiently and what are the various protocols we have, limitations and future scope we are going to discuss about. So when we comes to this MAC protocol in wireless sensor network, so in this topic we'll come to know about various issues of MAC protocol for sensor networks and challenges that are going to be faced. And these are the various kinds of sensor nodes that want to get access to that particular medium. When the nodes send the packet, there is no collision either in the midway or at the receiver side. So there should not be any collision due to two or more nodes are attempting to send the data at the same time at one particular point of time. If two nodes are sending the data, then there should not be a collision. So how do we ensure that that particular different nodes they send the data at different point of time? So a MAC protocol is the protocol that controls access to the physical transmission medium on any local area network. So it tries to ensure that no two nodes are interfering at each other's transmission and deals with the situation when they do. So when we comes to the major issues of wireless sensor networks, there are various kinds of issues are there which can affect the transmission. So the first one is called R2plex. In this case, the two-way communication is possible, but not at the same time. Simultaneously, two-way communication is not possible, but one after the other, they communicate from source to destination. So in this case, there is no possibility of getting detection. At the same time, these whatever the link we are using, that is called uplink and downlink, they must be multiplexed. The second issue we have is time varying the channel. So in this, because of this, we may face the reflection, diffraction, and scattering. These things we may face during the time varying channel. Different version of signals are imposed on each other, so the multipath propagation is also possible because of this time varying channel. The third issue we are going to discuss is burst channel errors. So usually we may have that BERs. So when high rate of BERs are there, or the errors occur in long bursts. In this case, the link layer will be retransmitted based on the acknowledgements, immediate acknowledgements received by that particular sender. So location dependent carrier sending in the sense, so we may have in a particular network, we may have hidden nodes or hidden terminals, we can call it as, or exposed nodes or capture nodes. These three kinds of nodes are available in location dependent carrier sensing. So hidden nodes in the sense a particular node does not know the other node is talking to that base station. If two nodes are there, A and B, the node A doesn't know that node B is talking with the base station. In that case, we can call this as hidden nodes. One node is hidden from the other node so that it doesn't know what activity is going on with other node with the base station. So in the case of exposed nodes, then again let us take two nodes A and B. So node A knows that node B is talking, but does not know what it will not. It doesn't know that it will not affect the node A conversation with base station. In the case of capture node, so A and B are both are transmitting that information to the base station, but since that node A signal is very strong than the node B, so the A's transmission use is initiated, so there is no collision is detected in the case of capture node. So when we comes to the issues related to accessing, there are three accessing mechanisms are there: random accessing, guaranteed accessing, as well as hybrid accessing. In the case of random accessing, this particular accessing is, or the communication is based on talk whenever we want. When a particular node want, at that time it can able to talk with others. So this way of thinking is will be available in random access. So in this case, the collisions may be resolved by there is some sort of mechanism we need to solve the collision problems. So the contention resolution algorithms are used to overcome the problem of these collisions. So usually when we have random access, the sort of network should be in distributed manner. So it supports the distributed network. When the second case of the access is called guaranteed access, so that means what? Whatever the resources available, it should provide guaranteed service for that particular communication. So that means every access, whatever the communication access we have, so every access to that particular medium is scheduled. That is well planned. So when multiple nodes are communicating with, when multiple nodes are trying to communicate with each other, in that case, it will follow the round robin mechanism. So based on that mechanism, the communication will be established. So when the round robin mechanism was involved in that communication, usually there should be a sort of client server mechanism or simply master slave mechanism. So among the nodes, one node is treated as a master and the remaining are slave. So master slave polling mechanism should have. And the examples for this guaranteed access is TDMA and FDMA, CDMA, like that. So time division multiple access, frequency division multiple access, and code division multiple access. That these three we will discuss now. So in these three cases, the time or the frequency or code is distributed equally for all the nodes. So based on the time or based on the frequency or based on the code, the communication will be accessed. So when we comes to hybrid access, hybrid, the name itself suggesting that it is having the characteristics of mixing characteristics like random access as well as guaranteed access. So both qualities are there in hybrid access. So it will be operated based on the request grant mechanism. So the source has to request, the receiver has to grant the permission so that they can communicate with each other. So the requests are the random access. When it is sending the request, it is in the form of random access. But once that particular communication channel is reserved, then that particular transmission becomes guaranteed. So the random reservation access is there according to this hybrid. These are the various issues we need to consider when you are going to design a MAC protocol. So when we comes to the layer architecture where this particular MAC is available. So we have, that we have 10 layer architecture, 8 layer architecture, 7 layer and 5 layer architectures are there. Based on according to the OSI, based on our requirement, we may have any number of layers. We may add one more extra layer or we may remove the existing layer from that architecture. So here this MAC layer is available along with the data link layer. So the routing will be performed at network layer and the congestion control will be performed at transport layer, and at the MAC layer the reliability flow control multiple access will be performed. So the MAC layer of this particular we can call this sub layer of this link layer. So this layer which can control the radio directly and it cares about the neighbors of that particular node. So now let us go for the classification of MAC. So based on the strategies or based on the approaches we have, the MAC is classified into two categories. So one is called scheduled based MAC and the contention based MAC. So in case of scheduled based MAC based on the reservation as well as scheduling of different nodes to get access to that particular common medium. So it has to reserve before accessing that particular channel. The basic idea is that there is a central authority, like just like an access point in our network, which is used to regulate the access to that particular medium and the broadcasting schedule of different nodes. So the particular entity, that is entity in the sense the access point, will assign the different nodes which one to which one to get the access to that particular medium at different time slots. So for example, each of these nodes, they know that specific slot when they are going to attempt that particular transmission, or when they are going to reframe that particular transmission in the given slots or in the allotted slots that are not assigned to them by the access point. So for both downlink and uplink, there are different time slots that are assigned to these nodes individually. So these nodes know when they have to transmit, and this class of MAC protocols, they avoid different nodes sending the packets. They're sending the frames at the same time, and these frames are leading to collision somewhere in between the space. So the time divided into slots, and each node know when to transmit in the case of scheduled based. But there are some problems in scheduled based MAC. So there is a scalability problem as well as there is an adaptability problem. They are not that much efficient than other protocols we have in related to scalability and adaptability. So scalability is an important factor in designing an efficient routing protocol for wireless sensor networks. We know that very well. When we are a good protocol has to be scalable as well as adaptable to that particular changes in the topology of the network. So this scalable protocol should perform well even though the network grows the larger or the workload is increased. In the case of in the case of contention based, there is no division of time, there is no division of frequency, or there is no division of code. So simply based on the demand, when there is a need, it will use it to sense that particular environment. So as we discussed TDMA, FDMA, CDMA, no need to discuss much more about this. We are well aware about these multiple access schemes. So in the case of time division, each frame is divided into fixed number of slots, so that according to that particular slot, the event will be sensed. So in this case, whatever the total time we have, the total time is divided into subparts or some pieces. So because of this, it is not possible to detect any collision. So no collisions will be occurred in TDMA scheme. As well as the energy also efficiently used, because there is no collision, no retransmissions are required. So we can have the efficient energy. So when the when the nodes are changed, their position, it is difficult to accommodate. It is difficult to identify according to this TDMA scheme. This is one drawback. So another drawback is it needs some strict time synchronizations mechanisms. Whatever the synchronizations we have in TDMA, that needs to be improved. That's why we said there is a problem called scalability as well as adaptability and synchronization. In case of frequency division, whatever the bandwidth we have, the total bandwidth is divided into several pieces. So and each piece is allocated, we can represent as a channel. So total bandwidth will be divided into pieces, and each piece will be presented as sub-channel, channel 1, channel 2, channel 3, like that. In the case of code division multiplexing, in this the different codes we are using different codes to separate that particular transmission. So based on the code management, it becomes very critical as well as complex to manage the schemes. So the second criteria, the second kind of MAC based approach is called contention based approach. So in this contention based approach, what is the protocol, as the name suggesting that there are different nodes to access that particular medium, but based on the contention. That means the shared medium, whatever the channel, communication channel we have, that communication channel have to content to access that particular medium. And therefore, we need to have fixed time slots which are assigned to them. So, like in the case of scheduled based protocol. So in this, for example, let us consider the example. We have three nodes called A and A, B, C. So before data transmission, before transmitting the data from node A to node C, let us assume that node A is the source and node C is the destination. So if A first will have to contend for getting access to that particular medium. So first an RTS request is sent the RTS request will be sent from the node A. Then the node C will be the recipient or receiver. So it has to send the confirmation back to the A in the form of CTS. So when node A is sending a request to send, node C has to send the clear to send. That means only after node A has received the CTS corresponding to the RTS transmitted by the node A to node C, then it can start the transmission of data, and corresponding to the data sent, there are going to be acknowledgements that are going to be sent by the recipient node towards that particular sender. So in this case, the C is sending the acknowledgement towards A, and here when we consider A is the source and C is the destination, whatever the B, the node B, which is the neighborhood of the neighbor node of node A as well as node C. So node B have to wait until the channel becomes free. So when the node B says that there is an RTS is being attempted between A and C, it will be refrained the transmission during that particular transmission period. So there is a possibility of when collision avoidance. So if you avoid the collision, we can improve the performance of that particular network. So as well as as this contention based is having the sort of handshaking, that is the sender is sending RTS, the receiver is sending CTS to the sender. So when both these communication is happened, that means they are shaking the hand. So they are agreed to communicate with each other. So in this also we have various examples for contention based MAC, Aloha as well as slotted Aloha. So in pure Aloha, what is going to be happened is when there is a data, it is sending. According to the Aloha, when the data is available, it will send the data. In the case of slotted Aloha, if that particular slot is not available, it will send in the next slot. So when there is a collision, they has to retransmit. So from the figure we can observe the basic difference between Aloha and slotted Aloha is in Aloha there is no time slots, but in slotted Aloha we can see the vertical lines which are time slots. So based on these time slots the data will be transmitted. Here we can see the A is sending during that period, B is waiting here, B is acknowledging and sending like this. There is some sort of collision. So when there is a collision, it has to be retransmit again. In slotted also, there is a possibility of collision, but it has some boundaries. We can call this as slots. So based on these slots, the data will be transmitted. If it is available, it will send the information in that particular slot. If not, it will check for the next slot which is freely available. So another example for contention based MAC is CSMA, carrier sense multiple access. So the basic idea behind this CSMA is before transmitting the data, it has to listen. It has to sense the environment. So based on that, it will decide whether to transmit or not. If when it is going to be transmit, when the channel becomes is idle, when the channel is free, then it is sending the data. If it is busy, then it has to wait until the channel becomes free. So to avoid this particular collision, we are going to have CSMA with collision avoidance. So in this case, as we discussed in slotted aloha, there is a CTS and RTS kind of approach. So after the handshake, the data will be transmitted in this. So when we compare the scheduled based and contention based algorithms, so in case of collision, these scheduled based protocols are there is no collisions in scheduled based protocols, but there are collision in contention based. And in case of energy efficiency, the performance of the scheduled based protocols is good, but in contention based, it needs some improvement to save that particular energy backup. In case of scalability adaptability, there is a problem in scheduled based as we discussed. There is a need of improvement in synchronization as well as adaptability features, but in contention based, these features are good enough. In the case of multi-hop communication, the scheduled based protocols will not perform that much efficient, and we can deploy the multi-hop communication in easy manner in contention based. Time synchronization, it is maintaining strict time synchronization, or this time synchronization is not required in case of the contention based. The hidden terminal problem. So here, if you consider the nodes A and B, C, A and B are in one virtual range. At the same time, B and C are in some other virtual range. That means A can communicate directly with B and C can communicate directly with B, but A will not communicate directly with C, as this A is not in the range of C or C is not in the range of A. So in this case, A is hidden from C as well as C is hidden from A. So we can see from here, node A is hidden from C as it is no way connected with C. These two can communicate directly and B and C can communicate directly, but the node C doesn't know what A is sensing. And in the case of exposed terminal problem, here if we consider again no need to have in brief. So let us assume that if we have these four stations, we have station A, B, C, D, and in this case, so station B as well as station C are transmitters, station A and station D are the receivers at some particular slot of time. Let us assume that. So the stations are in the configuration such that two receivers, that is STA and STD, are out of radio range of each other. So they cannot communicate directly, but the two transmitters B and C are in the radio range of each other. They can communicate directly. So the exposed terminal problem is solved by this particular MAC, Medium Acces Control layer, which is worked on the basis of IEEE 802.11 RTS as well as CTS basis. So with the condition that these two stations are synchronized and frame sizes, data speeds are same. So this approach will be worked perfectly when the data size is same, frame size is same, and they are synchronized. So the transmission stations sends, that is STB and STC sends the RTS frame to the receiving stations, that is STA and STD. So these receiving stations has to reply the CTS frame to the senders, again STB and STC. On receipt of CTS frame, the transmission stations they will start the transmissions. So any station hearing RTS is close to that particular transmission station and remains silent for a particular period of time to reach CTS. So any station hearing that CTS is close to the receiving station, then it remains silent during that particular transmission. When the data is transmitting during that period, it becomes silent. So the station STC hears, it may hear, the station STC may hear RTS from the station B. Initially, the intention is the station B is sending RTS request to station A, but at the same time, simultaneously, STC also can hear the RTS request from station B, but it does not hear CTS from the station A. It is sending the RTS request, STA is sending the CTS response to STB, but the STC doesn't know the STA is sending the response to that corresponding RTS request. So it is free to transmit to the station, that particular station D. This is exposed terminal problem. So what is the need of MAC for wireless sensor network? So the sensor networks have the multi-hop pattern of communication between the different nodes. As we know that it will be sending the sensor data over a multi-hop path across the different intermediate nodes in the route until the data is received by the single node. So we cannot use the traditional as well as single hop based network MAC protocols like traditional just like CSMA. So the wireless network or the other infrastructure based networks, we cannot use them because here we have multi-hop communication pattern. There is no single hop communication pattern. So these sensor networks are heavily constrained by the various factors. Among them, energy is one of the major factors. So each of these nodes are severely energy constraints, as every node is trying to save its energy. So corresponding to that, all these MAC protocols that are proposed for ad hoc networks or even for other infrastructure based networks, we cannot use them here because these sensor networks are much more energy constrained than the other ad hoc networks or other wireless networks like cellular network or some Wi-Fi. So thousands of sensors in a particular region. These nodes, once we deployed, they will have itself. They have to organize itself. The network will have to be formed. So these requirements cannot be that much easy for the traditional protocols like traditional MAC protocols like FDMA, TDMA, and CDMA. So instead of these protocols, we need to have new protocols for use of support these particular features, whatever the features we have. So these networks, in case of these networks, once deployed, they will have to form the network infrastructure, the topology of their own, and these networks should allow the fair and efficient sharing of that particular medium that is being shared by these sensor nodes, whatever the nodes we have in this network. So as we said, energy efficiency is one of the major factor. So when we look at the energy issue from the sensor network point of view, the first thing that is very important is the problem of idle listening. Simply it will listen, even though there is no need of sensing the environment, but simply they will listen. So in sensor networks, applications which have very light traffic, very less traffic, basically what happens is when we deploy that particular different nodes in such kind of environment, and if these nodes are continuously sensing, so because of this continuously listening, so much even though there is no change in the environment pattern or event pattern, still the sensor nodes, they will have to sense the medium unnecessarily. In spite of that, there is no additional information that is going to be associated with that particular sensed information. So unnecessarily, even though it is not required, because of this idle listening, there is the energy is going to be wasted. So the next issue is to waste the energy in wireless sensor network is collision. So the collisions are also very important in the case of sensor networks. So these sensor networks in the particularly the format of data or flow of data from the source node towards that particular sync node. So the downstream nodes, they are vulnerable to having that particular packet collided because the multiple nodes from the upstream have sent the packet at the same time due to the that there is some event that has occurred, and they may be together. So all these nodes that are sensed that particular event, they reported their event to the next top neighbor. So there is a chance of collision because both of them have reported the event at the same time. So generally, obviously, these collisions would lead to the packet corruption, and the packets will have to be discarded, and that is the reason the collisions will lead to that further wastage of energy, and we need to overcome these problems, collision problem. So another problem we have to waste for the source of energy wastage is called overhearing. So in this when the traffic is heavy, when the traffic is heavy and the sensor nodes are densely deployed, overhearing is happen because of its open medium, as well as the different nodes are trying to communicate. The different nodes are trying to communicate with each other with that corresponding neighbors, and in this process what happens is that there are others who are not intended to receive that particular information who are going to overhear the transmissions, and this is the reason that overhearing going to lead to be wastage of energy. So the other issue for the source of energy wastage is called protocol overhead. The MAC headers and the control packets that are used for signaling, they basically do not directly contain any actual data that carries that particular information. Therefore, they are the source of overhead. So it leads to protocol overhead and additionally unnecessary consumption of that energy. So the last issue for the source of energy is called traffic fluctuations. So a sensor event will lead to sudden peak in the sensor network traffic, and that fluctuation that surge all of the sudden due to the event, that is there is a sudden upsurge in the network traffic, and that this particular this phenomenon, it leads to unnecessarily increasing in the probability of collision, and basically it is going to be waste that energy. So collision, from the figure we can observe, A is sending the initiating the transmission. At the same time, B is also initiating the transmission. So from the B side, it will detect the collision. And in the fourth exam, in the fourth is in this one, A detects the collision before just ending that. If we consider this, the bottom image, this is the example for the collision in the Ethernet. So let us assume that node A is transmitting the information to node D. Let us assume that. So node A is initiating that packet transmission. It has to check if that this particular cable is clear or not. This particular cable is free or not. So it transmits the packet while listening to that particular cable. So node A transmission reaches to node C. Let us assume that at that particular moment of time, node C accomplishes that it is initiating the packet transmission. So in that case, so the collision may happen on the cable planet. So because of node A and node C are communicating at the same time simultaneously, So all the stations invoke that the algorithm called backup algorithm. They has to wait. So this difference should allow the cable plant to stabilize so that it becomes free. So when the cable is clear, when the cable plant is clear, it will be available for any station to transmit, any node to transmit. So no special treatment is given to the nodes that are involved in that particular collision. Simply, it has to retransmit again. It is the hope of that backup algorithm that no two controllers will generate the same two backup times and attempts to simultaneously transmit the data. So even if they do, they may get the error or they may get the corruption that corrupting that particular packet. So it will generate longer backup with each successive collision. These are the various ways of collision, examples of collision. So when we comes to Mac performance, to for a particular operation to make that particular operation efficient, so these networks, that wireless sensor networks, needs to provide some quality of service parameters to as the performance indicators. So there are various issues with respect to Mac protocol design. So these are the certain quality of service parameters which will provide the guaranteed quality of service factors. So among them, effective collision avoidance is one of the factor, the feature of MAC layer. So in this case, what is going to happen is for any design of MAC protocol which are using in wireless sensor network. So this is very important factor that it can task all MAC protocols that are designed for the use not only in the wireless sensor networks but any kind of network. These collision avoidance is very important. And the second factor is scalability and adaptability. Scalability is nothing but when we are increasing the network size, so how good the MAC protocol that we are designing will accommodate that particular changes. Adaptability means the sensor network becomes more and more density slowly or at some point of time or at some particular part or throughput, then how the performance of that particular MAC protocol is going to be. So the another factor, efficient channel utilization. So in this, according to this, how we are effectively using that particular channel, like bandwidth or other resources. So latency, throughput, fairness are the issues that are also applicable for the MAC protocols that are going to be designed for the ad hoc networks or other some wireless sensor networks. These are the different factors that have to be taken into account while designing a MAC protocol or the sensor networks. So these are the basically determines the performance of MAC in sensor network. So let us discuss some of the protocols of MAC for wireless sensor network. So contention based protocols, TDMA based protocols, self-organizing MAC protocols, SMAC and mobile sensor network MAC protocols. They are the various kinds. So let us have the contention based MAC protocol. So in this, the first well-known contention based MAC protocol that have been designed for sensor networks are the preamble sampling and WiseMAC. So these are the two protocols. In preamble sampling, there is a sending node and there is a receiving node. So we can observe from this first figure. So what the sending node does, it keeps on sensing the channel, and then if it sees that there is a sender node which is trying to send the packet, so this packet has basically a preamble to it. Then what is going to be going to do is it is going to activate the sensing and it will start sensing continuously for a particular packet. So consequently, what will happen is once the preamble is detected, then the data are going to be sent by the sensing node and will be received by that particular receiving node. So in the case of WiseMac, it is also very similar to this the first one, as we can see that almost similar kind of approach we have in WiseMac also. But in addition to that, in addition to the first one, in addition to the primable sampling, the data sending and the data receiving kind of scenario, but also we have acknowledgements that are sent back by the receiver node corresponding to every data unit that is received by it from the sensing node. So only the acknowledgement will sending in WiseMac, but in primable sampling there is no kind of acknowledgements. So when we comes to the TDMA variants, we have various protocols here: enhanced MAC, lightweight MAC, adaptive and information centric MAC, Zebra MAC, traffic adaptive medium access MAC. So in this case, these EMAC, enhanced MAC, is also a well-known protocol which is based on TDMA, where each time slot is divided into three sections. Every time slot is divided into three sections called contention based, as well as contention section, traffic control section, and data section. And here the nodes are divided into the active nodes and passive nodes. Along with that, there is a third category called dormant one. So we know active and passive. The dormant means that is more serious kind of sleep state, which means that most of the hardware circuitry in a particular dormant state are basically turned off. So the hardware is turned off. In the case of LMAC, lightweight MAC, it is very simple kind of TDMA protocol, where these the sensor nodes is having its own specific slot in which they can transmit the data. Every node is going to have a specific slot or pre-allotted slot. So that slot is going to be used by this particular node. And every sensor node has its slot independent of whether the data is there for a transmission or not. It does not check for it. The third variant of TDMA is AI MAC. So basically, this is also an adaptive version of LMAC. That means, along with the LMAC features, it is also having the feature called adaptability, where the adaptability is based on the traffic conditions again. So if the traffic conditions changed, whenever these traffic conditions are changed, the different nodes that have already been that are already allocated some time slots, that schedule is going to be changed dynamically based on this change in the traffic condition. Whenever the traffic condition is changing, the schedule is also going to be changed in AI MAC. And the next is called ZMAC, Zebra MAC. So which will assign the sensor nodes a time slot, just like in TDMA variant. But along with that, it allows the nodes to utilize the slots that it does not own through the CSMA mechanism. So this is maybe probably the reason for Zebra MAC is there is a Zebra kind of approach. This is the reason why it is known as Zebra MAC. So the last one is traffic adaptive medium access. So in this case, this particular mechanism ensures that each node can now hit two hope neighbors and demand of its immediate neighbors. So each node is know where the two hope neighbors are there, at the same time what the immediate neighbors are required. So the next category of MAC protocol is self-organizing MAC protocols. So in this protocol, we discussed there are two examples. Okay, so in this, what the self-organizing MAC protocol is nothing but whatever the cluster we have, you can see here, whatever the clusters we have, each cluster is going to consider as one entity. So in these two examples, The leech protocol and the gangs protocol, which belongs to self-organizing MAC protocol, self-organizing MAC class of protocols. So both of these self-organizing protocols, they are based on the clustering approach. The gangs and the leech, they look like very similar when we see on that particular slide, because these are the clusters that are formed by these protocols. And the cluster heads in these protocols, they are going to act like the leaders in that particular cluster. Each and every cluster is going to have one cluster head which is acting as a leader, which are represented as squares in that particular cluster. So if we look a little bit closely, we will see that in case of leech protocol, the base station or the cluster heads have the direct connectivity. That is one hop connectivity we have. Every cluster head is going to have one hop connectivity with the base station. But in the case of this gangs protocol, we cannot see that these clusters have one hop connectivity. That means, so in the case of there is a multi-hop connectivity from the cluster head to the base station in case of gang protocol. These are the self-organizing protocols. So once they deployed, they are going to have they are going to organize themselves. So this the self-organizing protocol. There are four types of messages are there: type 1, type 2, type 3, and type 4. We can see from this image. So type 1 in the sense it will send a very short invitation for that particular destination or the neighboring node along with the ID of that particular node. So type 2 means when type 1 message is received by any node, it has to send type 2. So in response to type 1, the node has to send the type 2 message which contains the address of that particular attached node. It also, along with the ID of the node, it also sends the address of that particular attached node. So in response to type 2, type 3 messages has to send. So in this case, it includes the decision of sender about the communication or the schedule of sender's existing link. So in response to type 3, it has to type 4 message. It identifies that the time slots are available to both sender as well as receiver to determine the channel for the communication link. It will establish the communication link. The next category of MAC protocol is mobile sensor network protocol. So these are applicable primarily basically for the stationary wireless sensor networks, and these we cannot use or we cannot deploy or we cannot use a mobile sensor network environment like MMAC. It is an example for mobile sensor network MAC protocols, which assumes that all the sensor nodes are aware about their current location. So, which may have the adaptability feature also, which enables that particular protocol to adapt dynamically when any changes are occurred. So, the last category of MAC protocol is SMAC. So, next lecture, in sequence of lecture, we are going to have this SMAC protocol in detail. So, this SMAC protocol, when we have many different nodes that are to be deployed in a particular region. So using these nodes, the different virtual clusters are formed, and these virtual clusters there is a possibility of getting overlapped. So which means that there could be different nodes which are the bordering node between these different virtual clusters. So these bordering nodes, they are going to sense the schedules corresponding to each of these clusters. So in fact, we have different virtual overlapping clusters, and there is a source cluster containing the source node. At the same time, there is a sync cluster which contains the sync node, and the source cluster is going to initiate the transmission, and the different nodes within that particular cluster has to follow the same schedule. They are going to help in the process of that particular packet will be transmitted to the virtual cluster from one cluster to another cluster. So when the packet was there in one particular cluster, the other nodes which are helping in this particular process, they all were following the same schedule, and then it was transferred to the border node to the next cluster and so on until the packet is received by the sync node in that particular sync virtual cluster. So here in like this in SMAC, the major goal, the primary goal of this SMAC protocol is energy efficiency, and there is a possibility of avoiding the collision so that it will reduce unwanted wasted transmissions, and it will having the capability to manage with hidden terminals as well as exposed terminals. And as these nodes are just like sleep wake cycle, it will manage. So simply it will sleep for some period of time and then wake up. It will check, it will sense that environment. If anything is new thing is happened, then that will be sensed by this particular SMAC protocol. So in SMAC also there are various features are there, which may some of the features may include like periodic listen or collision avoidance, adaptive listening, avoiding the overhearing or the message passing. They are the five important features of SMAC. So these five features we are going to discuss in the next lecture. Thank you.